So when we're determining the ionic formulas of compounds after they've had a chemical reaction, we know that in the first column is 1 plus, and the second column is 2 plus and 3 plus. On the other side of the periodic table, let's fold it in half, noble gases are neutral, so they don't have anything. We have 1 minus, 2 minus, 3 minus, so they kind of go opposite ways. But if you look closely at the periodic table, at iron, for instance, well, there's actually two different options for iron. Iron could be 3 plus or 2 plus. Cobalt's another one. Manganese is another one. Copper, nickel. There are quite a few elements that have two options, okay? So there's two different ways that they can actually react. So we need to know how to deal with those. So the note's called atoms of more than one ionic charge. So some atoms have more than one ionic charge. Example, iron could be either 2 plus or 3 plus. So there's two ways it can actually get a filled outer shell. Roman numerals are used to identify which ionic charge that we're talking about. So for example, if you wanted to use the iron with the 2 plus, okay, what we do is we use Roman numeral 2. If you're looking at iron with the 3 plus, well, we're going to use Roman numeral 3. And the way you write the formulas and the names is exactly the same. The only difference is when there's options, you want to tell the reader, well, was that iron 2 or iron 3? And we do that by putting in Roman numerals. So when iron 2 is combined with oxygen, which is 2 minus, the name of the compound is iron 2 oxide, and the formula is FeO. And I want to show you how we come up with that formula. So we have iron, we know, is Fe with a 2 plus, and it's 2 plus because it was indicated here. It's like, okay, I want you to use the iron with the 2 plus, so I put a 2 on top. Oxygen is a 2 minus. Then what I do is that crisscross thing. This 2 comes down here, this 2 comes down here, and I end up with Fe2O2. Now, we can actually divide 2 out of both of these, and you end up with FeO. And the reason we can simplify it down is kind of like common factoring in math. A 2 can divide out of both of those, so we're left with just FeO. And we would write the name as iron 2, Roman numeral 2, oxide. The Roman numeral is because there's two options, and you want to give the reader just insight of, was this the 2 or was this the 3? So let's try one more example over here. If it was iron 3 with oxygen, well, you write down FeO. The iron has a 3 plus, the oxygen is a 2 minus. And then just like before, we do the crisscross. So the 3 comes down here, the 2 goes down here. So this time you have Fe2, and then the 3 came down, so it'll be O3. There's no number that goes evenly into 2 and 3, so we just leave the formula as that, Fe2O3. And if you were to write out the name, you would have to write down iron 3, and we put the Roman numeral 3 because the charge on it was 3 plus, oxide. This 2 indicates I have 2 of those, and this 3 indicates I have 3 of those. Now, it says, in cases where there's only one ionic charge, do not use the Roman numeral system. So unless it's one of those common metals that you see there's two options, you don't need to use the Roman numeral system. We only put that down when there's two options. And there, for instance, aluminum, there's only one option for aluminum, so you know Roman numeral system. But if I look at something like gold, well, gold has two options, okay? It has two possibilities, so then I would need to use the Roman numeral system.